Okay, so what formula can we set up for this problem? Okay, since we know that the area of the sail is equal to 20 squared meters, so let's write that. A is equal to 20 squared meters. And we know that the area for finding the, we know that the formula for finding the area of a triangle is equal to 1/2 base times height. Okay, so given here that the base is equal to A plus 2 meters, so that's HL, and the height is PH. Okay, so it's also A plus 2. Okay, so that's also going to be A plus 2 meters. Okay, because we have here an isosceles triangle. It's a special right triangle. It's a special isosceles right triangle. So we have here PHL. Okay, so therefore PH is also A plus 2. So now we can solve for the value of A by using the formula of the area of finding the area of a triangle. So this gives us the area is 20 is equal to 1/2 multiplied by A plus 2 squared. Okay, because A plus 2 times A plus 2, so it's going to give you A plus 2 squared. Multiply both sides by 2 is going to give us 40. To cancel 1/2 is equal to A plus 2 squared. And therefore 40 is equal to A squared plus 4A. Okay, A squared plus 4A plus 4. Is that right? Because it's 2A plus 2A is 4. Okay, so this will give us A squared. Okay, A squared plus 4A, okay, plus 4 minus 40 is equal to 0. Because we have to transfer 40 to the other side. And therefore, A squared plus 4A minus 36 is equal to 0. So using the quadratic formula or your calculator, we can find the value of A. So it is equal, okay, so we've computed and the value of A is equal to 4.32. So that's A sub 1. And A sub 2 is equal to negative 8.32. Since we cannot have a negative value as a value of our A, therefore we take that the value of A is equal to 4.32 meters. Okay, so therefore to solve for the perimeter of this sail, okay, so we're going to have, okay, PH, okay, PH is equal to A plus 2, and HL is also equal to A plus 2, and PL is, okay, PL is going to be square root of 2 multiplied by A plus 2. Okay, so that's going to be A plus 2, so that's going to be 4.32 plus 2, so that's going to give you 6.32. This is also 6.32, and 6.32 times square root of 2, so that's going to give you 8.94. Okay, and to get the perimeter, so the perimeter is going to be 2 PH plus PL, so that's going to be 2 times 6.32 plus 8.94. So this will give us, okay, 2 times 6.32 plus 8.94, so that will give you 21.58. So the perimeter of our sail here on this figure is going to be equal to 21.58 meters. Okay, so let's try the fourth problem about trigonometric ratio. So Annie was looking for her old favorite books in their basement. When she opened the trapdoor of their basement, she shined a light vertically, and the light that penetrated to the floor of the basement is given by the distance of the points L and A. Okay, so there you go. So given that the width of the light penetration of the floor is equal to LA, which is equal to 15 meters. Okay, so this is kind of like the entire light, okay? Okay, so that's 15 meters. And the light shown at an angle of 54 degrees, find the height of the basement, so that's CL. So how do we do that? How do we find the value of X? So we can use one of the 6 trigonometric ratios. So we have here, what we're given here is, this is theta. Okay, so this is our theta here. Okay, let's use black. Okay, so this is theta. Okay, so we have here the opposite of theta is given. Okay, so that's opposite. and the adjacent is the one that we need to find. So therefore, we can use TOA. Is that right? Tangent, tangent, TOA. Okay, TOA, tangent is equal to opposite over adjacent. Okay, so let's use that one. So that will give us tangent theta is equal to the opposite side over the adjacent side. And tangent 54 degrees is going to be equal to the opposite over the adjacent. Now we don't know the adjacent side, so we just simply write A. Okay, so that will give us A tangent 54 is equal to 15, and the value of A, which is also equal to the value of X, which is also equal to the value of CL, and which is the basement's height. Okay, the basement's height. Okay, so if we solve for the value of A, okay, so there you go. We will have solved for everything. So 15 all over tangent 54. Okay, so let's check on our calculator. So that's going to be 15 all over tangent 54. Okay, so that's equal to 10.90. Okay, so A is equal to 10.90 meters. So if the light shown there on the basement is 15 meters from from points L to A, so therefore the height, okay, the height of the basement, okay, using the tangent trigonometric ratio is equal to 10.90 meters. Okay, so there you go. Okay, so let's try to solve for some more problems. Theo wants to get his driver's license at a young age of 17. To do so, he has to complete a driving track in the shape of a right triangle. So the track is given on the image on the right. Okay, find the value of theta or the angle at which Theo has to make a decisive turn for his practical tests, given the side measurements on the right. Okay, so what we're given here is this is theta. We need to find the value of theta, this one, given the opposite side and the adjacent side to theta. And again, one of the trigonometric ratios, or the only trigonometric ratio that we can use there. Okay, we can both use tangent and cotangent, but since tangent is one of the main, okay, so let's try to use that one of the main trigonometric ratios. So tangent is equal to opposite over adjacent side, and since we don't know the value of theta, so we simply put it like that, which is equal to the opposite side, which is 21.5, all over the adjacent side, which is 36.3. To solve for the value of theta, so we have to use the inverse of that one. So that's going to be tangent, okay, the inverse of tangent 21.5 all over 36.3 to solve for the value of theta. Okay, so using your calculator, how can you find the inverse tangent? So you just press shift. Okay, so you press shift, this one, shift, and then you find tangent. Okay, tangent. Okay, so you press that. Okay, so shift tangent, and then you input. Okay, input the fraction that you have there. So that's 21.5 all over 36.3. So 21.5 all over 36.3. Okay, and then just put a close parenthesis on that one. Okay, so there you go, and that's going to be equal to, okay, so it's equal to 30.64 degrees. Okay, so therefore, okay, theta is equal to 30.64 degrees, and therefore Theo must make a 30.64 degree turn to pass his test. Okay, so there you go. That's the answer. Okay, so let's try this one. Susan wants to know the height of the intravenous bag holder, intravenous, the IV bag holder in their ward, given that the intravenous bag makes a slant height of 17 foot. Okay, so the slant height is 17 foot from the sunlight coming to the opposite window, and the angle opposite the shadow that measures 67.93 degrees. Find the height of the intravenous bag holder. So to solve for this one, what we're given is the angle and the hypotenuse. Okay, so this is theta. Okay, so let's always try to situate or find where theta is. Okay, so theta is here. We're given the hypotenuse, and we have here an Okay, we have here an adjacent side. So we can use cosine. Okay, because we have here ka. So ka, okay, cosine is equal to adjacent over hypotenuse. So we can write here cosine theta is equal to the adjacent side over hypotenuse. And we know that cosine theta, okay, theta is equal to 67.93 is equal to the adjacent side, which is x. Okay, we don't know the value of x, all over the hypotenuse, which is 17. So this gives us 17 cosine 17 times cosine 67.93. Okay, so that's going to be the value of x. Okay, so let's check. So cosine 67.93, so that's equal to 0.3757. Okay, so on and so forth, times 17, so that's going to give us 6.39. So the value, okay, 6.39 feet. The value, okay, the height of the intravenous bag holder or the IV bag holder, the height, okay, the height of the IV bag holder is 6.39 feet. Okay, so it's quite a tall or an average sized IV bag holder. Okay, so for the last part of our lesson, let's have a look at our enrichment, angles of elevation, and depression. So as an extension of our topic about trigonometric ratios, let's look at the two most common scenarios in geometry wherein you'll use your knowledge about trigonometric ratios: the angle of elevation and the angle of depression. So the angle of elevation is the angle between the horizontal line and its site and the object, and the angle of depression is when you look down from a certain place. If an entity looks down at an object, the angle of depression is the angle between the horizontal line and the site of the object. So for example, we have here, okay, so let's try to zoom that one. Okay, so the angle of elevation will be if you're going to look up. Okay, for example, we have this girl, okay, this lady who's looking upwards at the hot air balloon, so she has an angle of elevation of 29 degrees, and the person who is on the hot air balloon is looking down at the lady from the ground at an angle of depression, which is 29 degrees. Okay, so let's try to solve let's try to apply our knowledge about angle of elevation and depression using these word problems. Okay, so we have here the first one. Melissa is a leading botanist and a geneticist in her field, and she wants to say goodbye to her beloved Mark on board of Space Shuttle Haribon, okay, or SS Haribon. Mark is an astronaut who were best friends with Melissa years back and in their elementary years. They drifted apart but found each other once again when they were working on a project in the OST on their Martian flight, okay, from the SS Haribon in the Philippines in the year 2045. Melissa is standing 897 feet from the launching station as she ran towards Mark to say goodbye. So from an angle of elevation of 67.90 degrees, Melissa looked up at Mark's space shuttle. Determine the distance of SS Aguila from the ground, x feet. Okay, so given our information here, we need to find the value of x of this one. Okay, so how can we do that? What trigonometric ratio can we use? So since this is the opposite side, and this one is the adjacent side to the angle of our angle theta, okay, so theta is equal to 67.93 degrees. So therefore, we can use tangent. Okay, so tangent, okay, theta is equal to the opposite side over the adjacent side. And this will give us tangent theta is going to be opposite. Okay, tangent theta is going to be 67.93 is equal to the opposite side, which is x, all over the adjacent side, which is 897. Therefore, the value of x is going to be tangent, okay, it's going to be 897 feet multiplied by tangent 67.93. And if we evaluate that on our calculator, so we have your tangent 67.93 times 897. So the distance, okay, of the SS Haribon from the ground is 2,000. Okay, 2,212.37